Alright, so you have watched the video on what vectors are. So we know that we are measuring our magnitude and the direction. So if we're going to look at example 1 and we want to know, okay, are these equivalent? So I know that in the Khan Academy video they talk about you can find the two legs of a right triangle and then know the hypotenuse and figure out the magnitude, which works great and it's a lot easier, but in cases where you just have points or if it doesn't start at the origin, then the distance formula comes in handy to figure out the magnitude or length, the distance of the vector. So we're going to look at example 1 and they're saying, are these vectors equivalent? So I need to see, do they have the same length and are they moving in the same direction? So let's start with length first. So we're going to do this using the distance formula, and like I said, if you have a perfect right triangle that starts at the origin and want to use it that way, that's fine, but I'm going to show you this way as well. So we know our distance formula, so I'm just going to label these x1, y1, x2, y2. So if I want to know the distance, it's going to be 3 minus 0 squared plus 2 minus 0 squared. So I have the square root of 3 squared plus 2 squared equals the square root of 9 plus 4. So my magnitude of u is square root 13, so I want to see if this has the same magnitude. So x1, y1, x2, y2. So 4 minus 1 squared plus 4 minus 2 squared. So I get 3 squared plus 2 squared, looking the same, so it's also going to be the square root of 13. So the magnitudes are the same. Now we want to see if our direction is also the same. So we're going to figure this out by looking at the slope. So I'll keep these points up here. So if we remember, slope is y2 minus y1 over x2 minus x1, change in y over change in x. So if we look at u, so that would be 2 minus 0 over 3 minus 0. So this one, my slope's 2/3. Let's do v now. So y2, so 4 minus 2 over 4 minus 1, 2 over 3. So our slopes check, so same magnitude, same direction. So yes, these are equivalent.